Okay, so the really nice thing about Chapter 9 is that it's almost identical to Chapter 8. We are still going to do our same 5 steps that we did in Chapter 8. So we're still going to have step 1 where we do our hypothesis, step 2 where we make our critical region, step 3 where we calculate our critical value, or our z value or t value, and then we reject or do not reject h sub 0, and finally write a statement by what that means. Okay, so we're still going to do those same 5 steps that we did in Chapter 8. Really, the only difference is going to be step 1. For step 1, you're going to have a different null and alternative hypothesis, which I'll write out here in just a second. All right. And then as you can see already, the z-score looks a little bit scarier than what it did in Chapter 8, but it's not too bad. This stuff up here is just something I typed out. Technically, you're always supposed to check to make sure these things have happened in order to do the problems. We will always be able to do the problems, so you don't really need to worry about that. Okay, so we're going to have our same 5 steps, but step 1 is going to look like this from now on, just for Chapter 9. So the tricky part when you put 8 and 9 together is to obviously know which step 1 you need to use. So your null hypothesis is going to be that mu1 is equal to mu2. Okay, so what we have is we have 2 completely different populations that we're comparing by comparing our sample data. All right, so we're comparing 2 different populations, whereas in Chapter 8, you were just doing one population compared to a number. All right, so then your alternative can be that it's greater than, that it's less than, or not equal to. Okay, so one of those. And again, it all depends on what the writing is. Okay. Now, there is a second way to write step 1. And that is, all we did is we actually moved this over to here. Okay, and the way we move it is that we subtract. So mu1 minus mu2 is equal to some number. So we could, instead of writing this, we could write equals 0. Our book doesn't do that, but some books do. All right? Or they might give you a specific difference. Is the difference less than 10? Is the difference equal to 12? If they give you a specific number for the difference, then you have to use this one. I promise you there is one in your assignment that you have to use this for. You will not have to on the test. Okay, so every Chapter 9 problem on the test will look like this. But in your homework, one of them will look like this because they're going to give you a specific value. All right, so then in this case, then your h sub 1 is either going to be greater than k, less than k, or not equal to k. All right, so again, one problem in your homework, and no, I will not tell you which one. You are going to have to write your step 1 this way rather than this way. All of the other ones, okay, all of the other Chapter 9 problems will look like this. One of them is going to look like this. All right. So once you get that figured out and then do step 2 where you look up either your critical regions with your z-chart or your t-chart. So 9.1 is going to be z-chart, 9.2 is going to be t-chart. You'll see how Chapter 8 and Chapter 9 are very similar. Okay, here's our z-score, which again, it looks really, really scary, but here's the nice part. So you're going to have 2 different sample means that you're going to have to subtract. This part right here, mu1 minus mu2. If this is what your step 1 says, mu1 minus mu2 then is 0. So most of that time that's going to be 0. So if mu1 is equal to mu2 in step 1, then this is 0. So you don't even have to type it in. Unfortunately, most of the problems are going to be mean and give you four 4 means. They're going to give you 2 population means and 2 sample means. So a lot of people think you need to put the population means in here, and you do not. They shouldn't even give you those because you don't use them. All right, so you'll see as we go along, but for every single problem except for one of them in your homework where you have to do this number is going to be 0. Okay, for that one problem, whatever k value you have here is going to have to go in here. All right, the other thing that's different is now we have a square root in the denominator, and we have sigma 1 squared plus sigma 2 squared. So if you remember, sigma is standard deviation. Sigma squared is your variance. This is both for population. So they're going to try to trick you, and if they give you variance, you don't have to square it. All right, so if the problem says the variance is 10, then you're going to put 10 here, not 10 squared. If they give you the standard deviation, then you do need to square it. So just look out for that. All right, as you can see, there's also another really scary formula down here, the confidence interval. So we're putting actually a confidence interval from chapter 7 into this as well. So I know this looks really scary, but remember, this is the middle part of your inequality. So this part right here and this part right here, those are the same. It's just this is the minus and this is the plus. Okay, so again, most people put a plus minus sign rather than writing the whole thing out. You just need to remember this is what goes in the middle of inequality. So in chapter 7, there was just a mu in there. In chapter 9, you need to put mu1 minus mu2 in the middle of your inequality. Okay, so again, we're going to use our z-chart because we know our population standard deviation or population variance. In 9.2, we're not going to know those, so we'll have to use our t-chart. So that's what you're going to have to look out for. All right, so here we go. A survey found that the average hotel room rate in New Orleans is $88.42 and the average room rate in Phoenix is $80.61. So there you can see we're comparing 2 completely different things. New Orleans and Phoenix, completely different. Assume that the data are obtained from 2 random samples of 50 hotels each and that the standard deviations of the populations, that's how we know that we get to use our z-chart, are 562 and 483 respectively. At alpha equals 0.05, can it be concluded that there is a significant difference in the rates? So that's what chapter 9 about is we're seeing, are these things different? Are these 2 means different? So step 1, mu1 is equal to mu2. Again, that's going to be the same for every single problem except for one problem in your homework. Alternative hypothesis then is it just says different, so mu1 is not equal to mu2. We don't care greater than, less than, just not equal to. All right, there's no word claim in there, so that means this one is going to be our claim. Step 2, alpha equals 0.05, so since it's a two-tailed test, that means 0.025 in both sides. Okay, that's 0.95, so 0.025 in both sides. So we look up in the big part of our chart, negative 1.96, so that one's positive 1.96. So remember, we look up 0.025 in the big part of your chart, just like we did in chapter 7 and chapter 8, and we find negative 1.96. Step 3, here's your new z-score. So we have 88.42 minus 80.61. Since this says mu1 equals mu2, again, it's going to be minus 0. You don't even need to write that in. Over a huge square root, 562 squared over 50 plus 483 squared, also over 50. The population or the sample sizes don't have to be the same. This one just worked out to be the same. So again, I want you to type this all in your calculator at one time. All right, the only parentheses you need are exactly where I have them. All right, so you have this here divided by square root. You don't need to put any more parentheses in there, and it should come out to 7.45. So that's a really big z-score. Step 4, that means we need to reject our null hypothesis. Again, 7.54 is going to be way out here. So we're going to reject. Step 5 then, since we're rejecting this one, we think this one is true. So that says the means are not the same. So there is enough evidence to support the claim, or you can just use the word conclude if you want, since that's what it was in here, that the mean room rates in New Orleans and Phoenix are different. Again, you can't say that we proved it. You can't even say New Orleans is more expensive than Phoenix, because that's not what it asked us to do. It asked us just if they were different. So that's all you need to say. You don't need to say that New Orleans is higher or anything like that, just that they are not the same. All right. I think I'll start a new video for the confidence interval.